Consider astronomy one of the most ancient scientific disciplines known to human mankind. The observation of stars and planets was well known already to ancient civilizations from the Mayan to the Babylonians, as is recorded by historical records such as astrolabes, like this one of Hispano-Moorish origin and this Japanese hemisphere based on a Korean map of the 14th century. The ancient Greeks had developed a very sophisticated astronomical system with Ptolemy in the 2nd century AD. In the Ptolemaic system, planets moved along orbital shells. This was the simplest astronomical hypothesis, but it required some tweaks to account for some anomalous phenomena. One of those phenomena, well known already to the ancient Greeks, was the so-called retrograde motion of the planets. During the course of the year, the trajectory of any planet in the blue sky at night appeared to form little loops. Now, to explain those loops, Ptolemy assumed that each planet moved along a small circle called epicycle, which in turn moved along a larger circle called deferens. But neither Ptolemy nor Ptolemaic astronomers believed that epicycles and deferens were necessarily a true description of planetary motion. They were more like mathematical contrivances or sophisticated hypotheses that could save the appearances, that could save the apparent motions of planets in the blue sky at night. The French philosopher Pierre Duhem, in a short but very illuminating book, which was written at the start of the 20th century called To Save the Phenomena, reconstructs the history of a physical theory from Plato to Galileo. And in that book, Duhem captures very well the spirit of ancient Greek astronomy as that of saving the phenomena. So there are lots of quotes from, for instance, Simplicius' commentary to Aristotle de Cielo that nicely captures this idea that the aim of science, the aim of ancient Greek astronomy, was not really to tell us a true story about planetary motion, but to provide us with a system of hypotheses that could save the appearances. So interestingly enough, for ancient Greeks, the aim of astronomy was not to provide a true story about planetary motion, but just to save the appearances. Not surprisingly, in 1543, when Copernicus' book De Revolutionibus Orbium Celestium was published, the book came out with a letter to the then Pope Paul III, where Copernicus very modestly presented his hypothesis as just another hypothesis that could save the appearances, although in a kind of more promising way than the hypothesis of his predecessors. This is what Copernicus says in the quote of Duhem. I began myself to consider the movement of the earth. It seemed an absurd notion, yet I knew that my predecessor had been granted the liberty to imagine all sorts of fictive circles to save the celestial phenomena. I therefore thought that I would be similarly granted the right to experiment, to try out whether, by assigning a certain movement to the earth, I might be able to find more solid demonstrations of the revolutions of the celestial spheres than those left by my predecessors. Despite the apologetic tone, Copernicus didn't hide too much his belief that his heliocentric hypothesis was more certain than any of the fictitious hypotheses of his predecessors. Yet Copernicus died the very same year in which his book was published. The book came out with an anonymous preface, which was very carefully crafted by someone called Andreas Osiander. And the preface somehow mitigated the spirit of Copernicus' work by presenting it as yet another exercise in this well-trodden tradition of saving the phenomena. For the astronomer's job consists of the following: to gather together the history of the celestial movements by means of painstakingly and skillfully made observations, and then to think up or construct whatever hypothesis he pleases, such that on their assumption the selfsame movements, past and future both, can be calculated by means of the principles of geometry. It is not necessary that this hypothesis be true, they need not even be likely. This one thing suffices, that the calculations to which they lead agree with the result of observation. No wonder the publication of Copernicus' book didn't set religious authority aflame until almost half a century later, when someone else dared to overthrow this received view of astronomy as just saving the phenomena, and dared to say that the Copernican system was actually true of the heavens. That person was Galileo Galilei.